refraction of light. So what is refraction of light? We have done the light property is that light travels in a straight line in one medium. But what happens if a light changes its medium? For example, if a light is moving in one medium and after that it enters the another medium, then what will happen? It is experimentally observed that the light changes its path, means show the bending property. So refraction is nothing, it is a bending of light when the light is traveling from one medium to another medium. In order to understand the refraction clearly, here I am doing a one activity. Here I am taking the two mediums. First medium is water and second medium is air. Here note one thing, that the line separating the water and air is a boundary, and where the light ray is strike, we have to draw the normal. Now make a incident ray from air, means light is coming from air to water. The point where it strikes, here the bending of light is now showing. How bending of light is possible? Understand one thing, that the water is different medium and air is different medium. The particles in the air is less. If the particles in the air is less, then no one is resisting or less particle resisting the speed of light. But in the water, particles are more, so they are resisting more light. If they are resisting more light, then the speed of light in water is less. Now in air speed is more and in water speed is less. There is some action takes place, so light show the reaction. The reaction is that the light is bending towards the normal. It means it is concluded that when the light is moving from rarer medium to denser medium, here rarer medium is air and denser medium is water, it is bending towards the normal. Repeat the experiment, but now the light ray is moving from water to air. The speed of light in water is less because particle is more, and the speed of light in air is more because particle is less. When the light is moving from water to air at the boundary, it is bending away from the normal. So it is concluded that when light is moving from denser medium to rarer medium, it is moving away from the normal. Let's see the meaning of optically denser and optically rarer medium. These are related terms, means relative to each other. For example, we have two mediums, air and vacuum. So here air is a optically denser and vacuum is a optically rarer. In vacuum there is no particle is present, so the speed of light in vacuum is maximum, that is 3 into 10 raised to power 8 meter per second. And the another term is air and water. Here water is optically denser than air. So we can say that optically denser and optically rarer are relative to the another medium. This is the table in which it is written that the speed of light in different mediums. We have to remember only the speed of light in vacuum, that is 3 into 10 raised to power 8 meter per second, and observe the other speed. You can see that when the optical density of the medium increases, the light speed is decreases. So we have to introduce the new term. Which is new term? This new term is a ratio of the speeds of the light in two mediums, and this term is called refractive index. Let us understand the term refractive index with an example. Here I am taking a glass slab in which light is coming from air to glass slab. Air is a optically rarer medium and glass is a optically denser medium. When light is moving from rarer to denser medium, it is bending towards the normal. Let the speed of light in air is V1 and speed of light in glass is V2. The refractive index of glass with respect to air is equals to speed of light in air, that is V1, upon speed of light in medium or in glass, that is V2. So refractive index is a ratio of the speed from where it is coming V1 to where it is going V2. Let's generalize the term taking glass as medium 2 and air as medium 1. So refractive index of medium 2 with respect to medium 1 is nothing but the ratio of velocity in medium 1 to the velocity in medium 2. We have two types of refractive index. First is absolute refractive index and second is relative refractive index. In absolute refractive index, medium 1 is a vacuum, and in the relative refractive index, medium 1 is other than vacuum. Why we are taking the absolute refractive index here? Because if the medium is vacuum, then the speed of light is maximum, that is 3 into 10 raised to power 8 meter per second. So for example, light is coming from vacuum to any medium. So refractive index of medium is nothing but velocity of light in vacuum, that is C upon V. Here the value of C is same, that is 3 into 10 raised to power 8 meter per second. And in the relative refractive index of medium 2 with respect to medium 1 is V1 by V2. Understand the term refractive index with an example. The example is like this. The absolute refractive index of glass is 2 and relative refractive index of glass with respect to water is 1.5. Now find the speed of light in water. Here see, the absolute refractive index of glass is 2, means refractive index is shown by symbol N. So Ng is given, that is C upon V. Here C is speed of light in vacuum, that is 3 into 10 raised to power 8 meter per second, and refractive index is given, that is 2. From here we calculate the velocity of light in glass, that is 1.5 into 10 raised to power 8 meter per second. Now the relative refractive index of glass with respect to water is given, that is 1.5. Now put in the formula. Relative refractive index means Ng with respect to W is equals to speed of light in water to the speed of light in glass. Here the speed of light in glass we have calculated, that is 1.5 into 10 raised to power 8 meter per second. Now multiply, we get 1.5 into 1.5, 2.25 into 10 raised to power 8 meter per second. So the speed of light in water is 2.25 into 10 raised to power 8 meter per second. See the principle of the reversibility of path of light. Let it understand with an example. A light is coming from first medium to second medium. The refractive index of second medium with respect to first medium, that is N21 is equals to speed of light in first medium to the speed of light in second medium, that is V1 by V2. Now reverse the path. Reverse the path means light is going from second medium to first medium. So the refractive index of first medium with respect to the second medium, that is velocity of light in second medium to the velocity of light in first medium. Now multiply these equations. In the right side we cancel each and everything, and here we get refractive index N21 into N12 equals to 1, and here we get N21 is equals to 1 by 2 N12. It means that the refractive index of medium 2 with respect to medium 1 is nothing but the reciprocal of the refractive index of medium 1 with respect to medium 2. Let's derive the relationship between the absolute refractive index and relative refractive index. I am taking the same example in which light is coming from first medium to second medium. The refractive index of second medium with respect to first medium, that is V1 by V2. Now see the absolute refractive index. Absolute refractive index of first medium N1 is nothing but C upon V1, and absolute refractive index of second medium is nothing but C upon V2. Here c is a speed of light in vacuum, that is 3 into 10 raised to power 8 meter per second, which is constant value, and v2 is the velocity of light in medium 2 and v1 is velocity of light in medium 1. Now calculate the value of v1 and v2 from this expression, that is here v1 become c upon n1 and v2 become c upon n2. Now put the value in the first equation. Here we get refractive index after cancellation, the relative refractive index, that is n21 is equals to n2 by n1. It means relative refractive index of medium 2 with respect to medium 1 is nothing but the absolute refractive index of medium 2 upon absolute refractive index of medium 1. See the relationship between the relative refractive index and wavelength. Here see one thing, that first of all we have to see the relationship between the velocity and the wavelength. We know that speed is equals to distance upon time. Here distance is nothing but a length of a wave, that is wavelength. It is represented by a symbol lambda, and 1 upon t is nothing but a frequency. So our velocity become lambda into frequency. Here frequency is depend upon the source of the light. So if the source of the light is same, then the frequency is same irrespective of any other medium. So here v1 become lambda 1 into f and v2 become lambda 2 into f. Now substitute the value in the relative refractive index, that is n21 is equals to v1 by v2. FF is cancelled and we get relative refractive index equals to lambda 1 upon lambda 2. Similar to reflection, we have a refraction in which incident ray is striking at the boundary of two mediums, medium 1 and medium 2. Here suppose medium 2 is optically denser than medium 1. So the light ray is bending towards the normal and this ray become refracted ray. Now draw the normal at a point of intersection at the boundary. Now the angle between the incident ray and the normal is called angle of incidence, and the angle between the refracted ray and the normal become angle of refraction. Now here are two laws. First law is incident ray, refracted ray and normal lies on the same plane, and second law is sine of angle of incidence to the sine of angle of refraction give a constant value, and this constant value is nothing but a refractive index, and this whole law, this second law, is nothing but a Snell's law. Let's see the two cases when there is no refraction of light takes place. It means the light is coming from one medium without showing any bending, it goes to second medium. The first case is when the angle of incidence is 0. When the angle of incidence is 0, the incident ray is coming with normal, so the angle of refraction is also 0. How? Sin I upon sin r is equals to constant. Sin 0 is 0, and from cross multiply we get sin r equal to 0. Sin r equal to 0 means angle of refraction must be 0. So the refraction becomes 0, the light is without any bending going in the second medium. This is the first case. And second case is when the two mediums have same value of refractive index, then the light is going without any refraction. Understand the property of refraction with the experiment of glass slab. Here take a glass slab on a white sheet and make the outline of the glass slab and name the glass slab as PQRS. Now make a inclined line on the PQ and fix two pins A and B. These two pins on the straight line means they are coincident with each other. Now put the glass slab again and see the pins from the SR side. You fix the pins C and D in such a way that they make a straight line. Remove the glass slab and extend the lines. The line AB, which is intersect at PQ, mark a point, that is M. and the line CD, which is intersect at S or mark the point as N. Now make a 90 degree upon M and N. These 90 degrees is nothing but a normal to the surface. Now you will observe that the line AB or AM is nothing but a incident ray, and join the line M and N. The M and line is nothing but a refracted ray, and there is a new line that is ND, and is nothing but a emergent ray. Let's see what is the meaning of emergent ray. When a ray of light is coming to a medium, means second medium, then from the first medium it is an incident ray from where it's originate. After refraction it become a refracted ray. Now this ray is going to the same medium, it become emergent ray. You have to remember the name. And now see the angles. The angle between the incident ray and normal is called angle of incidence. The angle between the refracted ray and normal is called angle of refraction, and both these are angle of refraction. And the angle of between the emergent ray and the normal is called angle of emergence. Extend the AB line. After extending, you will observe that the AB line and CD line are not coincident to each other. But before going to do the experiment, in the experiment we have see that it must be coincident. Then how is this happening that they are not on a same line? This is because of refraction of light. Due to refraction of light, the emergent ray become shifted from actual incident ray, and this shift from the actual incident ray is nothing but a lateral displacement. Let's see the relationship between the angle of incidence and angle of emergence. Before going to the relationship, first of all understand what is the meaning of second law of refraction. Second law of refraction states that sine of angle of incidence to the sine of angle of refraction gives a refractive index. Here in this example, refractive index of glass with respect to air is nothing but sine I upon sine R. In the second case, in the SR surface, sine of angle of refraction first and sine of angle of emergence second. Sine R upon sine E is nothing but NA with respect to G, means refractive index of air with respect to glass. Now multiply both these equations. After multiplying and apply the law of reversibility. Reversibility states that refractive index of glass with respect to air is nothing but a reciprocal of the refractive index of air with respect to glass. Now our right side become 1, and from here after cancellation we get angle of incidence is equals to angle of emergence. This result we can conclude that the line AB is parallel to the line CD, and the distance between the line AB and CD is nothing but a lateral displacement. Let's see the applications related to refraction of light. Our first application is when object placed in a denser medium view from a rarer medium, we see its depth less than their actual depth. Let it understand with an example. When a person is seeing or watching the surface of a swimming pool from the outside, he will observe that the surface is less than their actual depth. How is this happening like this? When a light ray is going from the surface of water to person's eyes, at the interface it bends away from the normal, because when the light ray is going from denser medium to rarer medium, it bends away from the normal, but our eye sees straight. Now extend this line to a straight. You see this extended line meet at a point above the surface of a swimming pool. Here we see the actual depth of the swimming pool, but the real depth is at the lower place. So we see the depth or imaginary depth less than the actual depth of the swimming pool. There are some examples related to the application of the refraction. You may note these examples. See, one example related to the refraction of light means second law of refraction of light. The example is like this. The diagram is given in this figure. First of all, see the diagram, and in this question it is asked to find the refractive index of medium 2. We know that the refractive index of medium 2 with respect to medium 1 is nothing but sin I upon sin r. Here angle 30 is given with the boundary. We have to take the angle of incidence with the normal, so its whole become 90 degree. So angle of incidence become 60 degree, and angle of refraction is given with normal, that is with refracted ray and normal ray, that is 45 degree. Now put the values. Sin I upon sin r is equals to mu, or that is refractive index n, 2 with respect to one medium. Here sin I means sin 60 degree upon sin 45 degree. Sin 60 value we know that under root 3 by 2, and sin 45 is 1 by under root 2. After solving we get under root 6 by 2, and this value is numerically approximately 1.22. So the refractive index of medium 2 with respect to medium 1 is nothing but 1.22. Our next topic is spherical lenses. Some of you wear glasses. Now see which type of material or what type of lens is used in your glasses. First of all, we should know what type of lenses are present in nature and which lens is used according to which problem. So if you see, the spherical lenses similar to spherical mirror are of two types, convex lens and concave lens. These both are made up of transparent medium. The convex lens is thicker from center and thinner from edges, and concave lens is thinner from center and thicker from edges. This convex lens is also called converging lens because a parallel beam of light passes from this lens, converges at a point, and this concave lens is nothing but a diverging lens in which parallel beam of light is diverges from a particular point. Let's see some terms related to the convex and concave lens. From this figure you can see that the convex and concave lens are made from the circles, and these two circles have their two centers. Now join a line from these two centers, you get a principal axis similar to convex and concave mirror. Now the height of the lens is nothing but the aperture of a lens, and the center of this lens where the height and principal axis is met is nothing but the optical center. Now what is optical center? Optical center is a point from which if light is coming, they goes out undeviatedly, and other part of the optical center, each and every part light get deviated. We have seen how to find the focus of a convex and concave mirror. Now similar to that method, we are finding the focus of convex and concave lens. We are putting the lens in front of a sun. From sun, parallel beam of light is coming, and in the convex lens, this is a converging lens, so whole the light is focused at a point, and this point is nothing but a point of focus. And on the other side, in the concave lens, these rays are diverges from a point, and this point is on the left side, and this point is nothing but a focus of a concave lens. The focus we get is nothing but a second focus. How we get the first focus? We have to make a ray in such a way that after refraction it become parallel to principal axis, and we get the first focus. Now you see that the first focus in convex lens is on the left side and second focus is on the right side, and on the concave lens the first focus is on the right side and second focus is on the left side. Now see the three diagrams related to the convex and concave lens. Our first diagram is when ray of light is parallel to principal axis, it passes from the second focus in both the convex and concave. And our second diagram is when the ray of light is passing from the first focus, it become parallel to principal axis. And our third diagram is when ray of light is passes from optical center, it passes as it is without any deviation. These three diagrams are very useful in order to make the ray diagram. Now we have to make the ray diagram in convex and concave lens, where we put the object at a position and then we get the image. In order to make the ray diagram, first of all we have to learn some things related to the ray diagram. First, we should know that the object should be placed on the left side and above the principal axis. If we get the image on the right side, then we get the image as a real image, and if we get the image on the left side, on the same side of the object, then we get the image as a virtual image. And if the object, or you can say that if the image is formed above the principal axis, then image is erect, and if the image is formed below the principal axis, then image is inverted. And if the size of the image is more than the size of the object, then size is enlarged, and if it is less, then the size is diminished. Let's start the ray diagram with the convex lens. In order to make the ray diagram, first of all, how we make the lens and where we place the object, how we place the object. Our first thing is we make a line, that is any line, PQ line, you can name the line, and then we roughly make a convex lens like this, and then make a aperture. Now the intersection point of principal axis and height or aperture is nothing but a O point. This is a optical center. Now make 2 points on the left hand side and 2 points on the right hand side at equal distance. These 2 points, first point is f1 focus 1 and second point is 2f1, double of the focus, and on the right hand side we have f2 and 2f2. Now our diagram is completed. Now we have to place the object. We have to place the object above the principal axis, means 1 centimeter line. Now if the image is formed on the right side, then we can say that the nature of image is a real image, and if image is formed on the left side, means same side of the object, then the nature of image is virtual. If the image is formed above the principal axis, then we can say that the image is erect, and if it is formed below the principal axis, then image is inverted. If the height of the image is more than the height of the object, the image is enlarged, and if height is smaller, then image is diminished. So in order to make the ray diagram, we have to make the box like this, in which we write the position of the object, the position of the image, size of the image, and nature of image. Let's start the first case, when object is placed beyond 2f1. Now make a 1 centimeter line above the principal axis beyond 2f1. Now in order to make the ray diagram, we have to take 2 rays from those 3. Our first ray is when line is parallel to principal axis, it passes from the second focus after refraction, and our second ray is when light ray passes from the optical center, it moves as it is. So these both rays meet at a point on the right side of the lens. The image is formed between f2 and 2f2. Now join this point with the principal axis, we get the size of the image less than the size of the object. Now start filling the table. The position of image is between f2 and 2f2. The size of the image is diminished. See the nature is nothing. like image is formed on the right side means image is real image, and formed below the principal axis, so nature is real and inverted. The second case is when object is placed at 2f1. Now make a 1 centimeter line at 2f1. Now we have to choose the two rays. Our first ray is when line is parallel to principal axis. After refraction from lens, it passes from f2, and a line when passes from the optical center, it passes away without any deviation. Now our image is formed at the point of intersection. Where we get the point of intersection? The point of intersection we get at 2f2. So the image is formed at 2f2. Where is the object? Object position is at 2f1. Image is formed, position of image is formed at 2f2. Size of image is same as the size of the object, and nature of image is, here the image is formed on the right side means real image is formed, and this is below the principal axis, so nature is real and inverted. Our third case is when object is placed between 2f1 and f1. Now make a 1 centimeter line between 2f1 and f1. Now choose the two rays. First ray is when line parallel to principal axis, it passes from second focus, and second line is when line is passes from optical center. We will get the intersection point beyond 2f2. So here the object position is between f1 and 2f1. The image position is beyond 2f2. The size of image is larger than the size of the object, so in large view. And the nature of image is, the image is formed on the right side means real image, and it is below the principal axis, so nature is real and inverted. Fourth case is when object is placed at f1. Now make a 1 centimeter line at f1. Now choose the two rays. First ray is when line parallel to principal axis, it passes through second focus, and second line is line passes from optical center. You will note here that these lines become parallel, so it will meet at infinity. So the position of the object is at f1. The position of the image is at infinity. The size of image is highly enlarged because when we meet infinity with principal axis, highly enlarged image is formed. And fourth is nature. Nature is image is formed on the right side, so real, and below the principal axis, so inverted. So nature is real and inverted. Sixth and last case is when object is placed between optical center and first focus. Now make a 1 centimeter line between O and f1. Now choose the two lines. First line is line parallel to principal axis, it passes from second focus, and second line is a line passes from the optical center. Now you observe that these lines are diverging on the right side, so it must be converging on the left side. So extend these lines to the left side, and here you get the point of intersection. Now meet the point of intersection with the principal axis. Now start filling the table. Where should the object be placed? Object position is between O and f1. The image position is beyond f1, or we can say that on the same side of the object. Now the size of image is larger than the size of the object means in large view. And nature of image is, here image is formed on the left side or the same side of the object, so nature is virtual and it is above the principal axis, so nature is virtual and erect. There is one case related to the convex lens. This is the case which we have done earlier in order to find the focus of a convex lens. The case is that when object is placed at infinity. When object is at infinity, a parallel beam of light is coming toward the convex lens, and after converging, it is converges to second focus. Now start filling the table. The object position is at infinity, image is formed at second focus. The size of image is point size highly diminished, so size is highly diminished, and nature of image is, it is on the right side, so real and inverted. Have completed all ray diagrams related to the convex lens. Now start the ray diagrams related to the concave lens. First of all, we have to make a straight line like this. This line is nothing but our principal axis. Now make a rough sketch of the concave lens. Now draw the aperture. The intersection of the aperture and the principal axis is nothing but the optical center. Now from the optical center, take 2 points at a same distance on the left side and on the right side. This is nothing but the focus. On the left side we have second focus and on the right side we have first focus. We know that the focus is different in the concave lens. First case is when object is placed at a finite distance from the optical center. In this case, you can put the object anywhere in front of a concave lens. Irrespective of the position, we get the same type of image similar to the case in front of a convex mirror. Now make a 1 cm line anywhere in front of a concave lens. Now choose the two rays. First ray is when line parallel to principal axis, it diverges from second focus, and second ray is line passes from the optical center, it passes away without any deviation. So the image is formed, the point of intersection, the intersection is between the F2 and O, means second focus and optical center. Now start filling the table. The object position is anywhere in front of the concave lens. The image is formed between F2 and optical center. The size of image is less than the size of the object, means diminished, and nature of image is the image is formed on the left side, means same size of the object. So the image is formed virtual and it is above the principal axis, so nature is virtual and erect. Second case is when object is at infinity. When object is at infinity in front of a concave lens, a parallel beam of light is coming and it is diverges from F2. So image is formed at F2. Now start filling the table. Object is at infinity, image is formed at F2, focus of the concave lens. Third, size of images, the image is formed highly diminished, point sized, and nature of image is virtual and erect because it is on the same side of the object. Let's see the uses of the convex and concave lens. Usually convex and concave lens used in the spectacles, or these are the lenses used in the microscope, telescope or any other magnifying glasses. In your daily life you have heard or you have seen so many cases when people not able to see the far object clearly and some old peoples not able to see the near object clearly. So they use the spectacles in order to clear their vision. Different people have different power of vision. Some people have -3.5 and some people have -1.5, some people have +2. So what is the meaning of this? This all nothing but a power of lens. So let us understand what is the meaning of power of lens. Of lens is nothing but the converging or diverging capacity of the lenses. Let it understand with an example. Here I am taking the two convex lenses. Convex lenses is nothing but a converging lenses. Now make a parallel beam of light. After refraction, you will observe that the convex lens is of higher power. It converges its ray at a short distance from the optical center than at its lens which is of lower power. So we can say that if the power is higher, then focal length is less after this observation. So we can say that power of lens is reciprocal of the focal length when focal length is in meter, and the unit of power is diopter. So the new term is, what is 1 diopter? 1 diopter is a power of lens when focal length of lens is 1 meter. One term is still left. What is the meaning of -2 diopter and +2 diopter? Here first of all draw the diagrams of convex lens and concave lens. In convex lens you will observe that the focus F2 is on the right side. It means the focus is on the positive side if we considered optical center as a origin. So f2 is on the positive side. The focal length of the convex lens is positive, so the people uses convex lens in order to clear his vision has a power in positive. And similar to the convex, we have a concave lens. Concave lens have a focus on the negative side. So focus is negative or power of lens is negative for the concave lens, and power of lens and focus is positive for the convex lens. One topic related to the power of lens, that is combination of power of lens. This is nothing but when so many lenses are in contact, then how we get the resultant power? The resultant power we get after summing up all the powers of each and every lens. For example, we have n number of lenses and its power is P1, P2, P3, P4 and so on up to P1. So resultant power is nothing, that is P is equals to P1 plus P2 plus P3 and so on up to Pn. Now here note one thing, that if the lens is convex lens, then we have to put the value in positive, and if the lens is concave lens, then we have to put the value in negative. For example, we have two lenses here. First lens is concave lens having power -3 diopter, and second lens is convex lens having power +2 diopter. Now they are contact with each other. Now find the resultant of the power of lens. So power of lens is nothing but the P1 plus P2. Here P1 is -3 diopter and P2 is +3 diopter. So the resultant is -1 diopter. From this you can also calculate the focal length if asked in the question. In order to understand the numericals, first of all we should know the formulas related to the lens, sign conventions and some terms related to lens. Our first term is U. Similar to the mirror case, we have U in which where should the object be placed. So U is nothing but a object position from optical center. V is a image position. F is a focal length of a lens, either concave lens or convex lens. Magnification, we know what is the height of the image to the height of the object, that is hi upon h naught. Here hi is height of image and h naught is height of object. In order to understand the sign convention, first of all make convex and concave lens below the coordinate axis. Here optical center is act as a coordinate axis, means origin of the coordinate axis. Now first of all see the object. Object is always placed on the left side, so object value is always negative because it is on the negative x-axis. Object is always placed erect, so object should always be above the principal axis. Next term is V. V is nothing but a position of image. If V value is positive, then image is formed on the right side. It means the nature of image is real. And if V value is negative, then image is formed on the left side, or we can say that the same side of the object. Then we can say that the nature of the image is virtual. The next term is F. We know F is nothing but a focal length of a lens. For convex lens, the focal length is on the right side, means on the positive side, and for the concave lens the focal length is of negative side. Now in the numericals, if convex lens is given, then we have to take the focal length as positive value, and for the concave lens we have to take negative value. Next terms are hi and h naught. Hi and h naught is nothing but a height of image and height of the object. Height of object is always positive because we place the object above the principal axis, and h naught is always positive and erect. Hi can be positive or negative. If hi is positive, we can say that the height of image is erect, and if hi is negative, means image is formed below the principal axis, then we can say that the nature of image is inverted. Next term is magnification. Magnification is nothing but the relation between the height of image to the height of object. So m is equals to hi upon h naught. If height of image is more than the height of object, then the magnification value is greater than 1, and if the magnification value is greater than 1, we can say that image is enlarged. And if the height of the image is less than the height of the object, then we can say that magnification value is less than 1, then we can say that image is diminished. Now here magnitude is more important, because if magnification value is -3, it seems that it is less than 1, but its magnitude value is greater than 1. So we can say that if magnification value is -3, then image is enlarged. Here negative sign only indicate that it is formed below the principal axis. See some formulas related to the lens. Our first formula is name itself lens formula. Lens formula is like this: 1 upon v minus 1 upon u is equals to 1 upon f. It is similar to the mirror formula, but here 1 upon v instead of plus, here is minus. And our next formula is magnification. In that case magnification is minus v by u, here magnification m is plus v by u. And standard formula of magnification is here also same, magnification is hi upon h naught. Now we have another formula that is related to the power of lens. We have done earlier, power of lens is nothing but 1 upon f, where f is in meter. The units are very important, because in the case of question power is given in the diopter, and when we find the focal length we found it in meters, so we have to convert in centimeter according to the question. Our first question is, when object is placed 50 centimeter in front of a lens which is having power of lens plus 4 diopter, then find the nature, position and height of image if size of the object is 10 centimeter. Before going to start the question, first of all make the rough sketch of the lens. Here in this question it is not mentioned that what type of lens is this. So first of all we have to read the question and analyze what type of lens is this. We have to analyze by power. Power is equals to plus 4 diopter. Here plus 4 diopter means the focal length is on the positive side, and we know that in case of convex lens we have a focal length on the positive side. So first our lens is find out, that is convex lens. Now make a rough diagram, and here object is placed 50 centimeter in front of a lens. So u is minus 50 centimeter because u is on the left side. Here first of all we have to find the focal length. We know that f is equals to 1 by p, but actual formula is p is equals to 1 by f. So if f is equals to 1 by p, now put the values. P f is equals to 1 by 4, we get 0.25 meter. Each and every data is given in the centimeter, so in multiply with 100 and we get focal length as plus 25 centimeter. Here h naught is given as, that is height of object is 10 centimeter. We have to calculate v, that is position of image, hi and magnification. The first formula we use, that is lens formula, that is 1 upon v minus 1 upon u is equals to 1 upon f. Now substitute the value of f and u in the formula. After solving we get the v value as 50 centimeter. V value we get positive 15 centimeter. It means image is formed on the right side of the lens. If image is formed on the right side, then we can say that the nature of image is real. Now calculate the magnification value. Magnification value is plus v by u. Here v is positive 50 centimeter and u is minus 50 centimeter. After cancellation we get magnification is equals to minus 1. Here minus 1 signifies that if we see the magnitude of magnification is 1, it means the size of image is same as the size of the object, and negative sign indicate that the image is formed below the principal axis. Now calculate the height of image. Magnification is equals to hi upon h naught. Hi value we have calculated and h naught is 10 centimeter. Magnification value is minus 1. So hi value after cross multiply we get minus 10 centimeter. it means height of image is 10 centimeter and image is formed below the principal axis, so image is inverted. So nature we get as real and inverted.